Welcome to the Deep Dive.
Yeah.
Today we're going to unpack this hefty report from the National Academies of Sciences, Engineering, and Medicine. NOSABENG.
You know him.
Yeah, you know them, right?
Mm.
Their work, The Age of AI and the Life Sciences. Benefits and biosecurity considerations is our focus. And let me tell you, it's fascinating, if dense. Look at how AI is changing biology as we know it.
Mm-hmm.
We'll walk you through each chapter.
Like a guided tour.
Exactly. Highlight the key takeaways. No commentary, just straight from the source.
Just the facts.
Just the facts. So let's jump right into Chapter 1, Introduction.
Sets the stage.
It sets the stage, laying out the report's purpose.
Yeah.
To assess the potential biosecurity risks and benefits of AI in the life sciences.
The whole spectrum.
Yeah.
Good, bad, and the potentially ugly.
Okay.
The committee behind this report really wanted to cover it all, how AI could be a force for good, rapidly developing medical countermeasures against diseases, but also the potential downsides like AI being misused to design dangerous biological agents.
To gather all those perspectives, they held 3 public meetings with experts from various fields. Talked about everything from the current state of AI tools in biology to how infectious agents work, developing medical countermeasures, managing biological data, and even the need for high-performance computing. They really did their homework.
They did, and that thoroughness is evident throughout the report.
Yeah.
For example, one concept they emphasize is capability uplift. They represent this with the symbol delta AI.
Okay.
It basically means how AI tools fundamentally change the game in biology, for better or worse.
So AI isn't just another tool in the toolbox, it's a game changer.
Precisely. Now, let's move on to Chapter 2. Design, build, test, learn. Impact of AI on the synthetic biology process.
Okay.
This chapter gets into the nuts and bolts of how AI is transforming the classic design, build, test, learn, or DBTL cycle in synthetic biology.
Okay, so the DBTL cycle is basically the scientific method on steroids, right? Design an experiment, build it, test it, learn from the results, and repeat. How is AI changing that?
It's like hitting the fast-forward button on the entire cycle.
Okay.
For example, in drug discovery, AI can generate thousands of potential drug molecules in just a few days, a process that traditionally takes years. That's the kind of speed AI brings to the table.
Wow, that's incredible. That could revolutionize how we develop new medicines.
Absolutely. And it's not just drug discovery. The report also highlights the use of scientific large language models, or LLMs, like CRISPR-GPT. These models are trained on vast amounts of scientific literature and can be used to synthesize information, help researchers formulate hypotheses, and even suggest new research directions.
So it's like having an AI research assistant at your fingertips.
Exactly. The report even suggests that these LLMs could eventually become full-fledged AI scientists, capable of conducting research independently. Now, combine that with the potential of automated laboratories or biofoundries, which can automate experiments and generate even more data to train AI.
So we're talking about a future where AI is designing experiments, running them in automated labs, and analyzing the data to generate new hypotheses. That's pretty mind-blowing.
It is. But as with any powerful technology, there are potential downsides to consider.
Right.
That's where Chapter 3 comes in. AI-enabled biological design and the risks of synthetic biology. This chapter dives into the potential for misuse of these powerful AI design tools. The report specifically emphasizes how AI could be used to alter the DBTL cycle for potentially dangerous applications.
So we've talked about AI accelerating the development of new medicines, but could it also be used to accelerate the development of, say, biological weapons?
That's a concern the report addresses head-on. And while they acknowledge that AI currently has limitations, those limitations are constantly shrinking. For example, while AI might not be able to design a full-fledged virus from scratch today, it could be used to design toxins that can evade security checkpoints.
That's a chilling thought. Are there any specific examples of how this could be done?
The report does highlight examples of how AI could be used to design toxins that target specific vulnerabilities in security systems, making them undetectable by current methods. This raises serious concerns about the potential for malicious actors to exploit AI for nefarious purposes.
That's definitely unsettling. What about the future? Are there any specific concerns about how AI capabilities might evolve in ways that could increase these risks?
Absolutely. The report raises concerns about future AI models being able to accurately predict how easily a virus spreads, the design of self-replicating organisms, and even designs that require less real-world testing. This could significantly lower the barrier to entry for bad actors and make it easier to develop dangerous biological agents.
So even if AI can't do those things today, it's something we need to be prepared for in the future.
Precisely. And to address these potential risks, the report offers a framework for assessing the level of concern for different AI-enabled capabilities. They consider factors like how usable the technology is, how easily it could be weaponized, what resources an actor would need to carry out an attack, and the potential for mitigation.
So it's not just about identifying the risks, but also about understanding how serious they are and how we can potentially mitigate them.
Exactly. And speaking of mitigation, the report also expresses concern about state-sponsored biological weapons programs, specifically mentioning Russia, North Korea, China, and Iran, and their potential use of AI in this area. It's a reminder that the stakes are incredibly high.
This is getting pretty heavy. But isn't it possible that AI could also be used to enhance biosecurity and counter these threats?
That's a great point, and that's exactly what Chapter 4 explores, promoting and protecting AI-enabled innovation for biosecurity. This chapter shifts the focus to how AI can be a force for good in the realm of biosecurity.
So how is AI already being used to improve biosecurity?
One example is in infectious disease surveillance. AI is being used to track outbreaks, identify hotspots, allocate resources more effectively, and even analyze news and social media for early warning signs of potential outbreaks.
That's pretty impressive. It's like having an AI early warning system for infectious diseases.
It is, and it's not just about surveillance. AI is also playing a crucial role in speeding up the development of medical countermeasures, like vaccines and therapeutics. Remember the rapid development of COVID-19 vaccines? AI played a big part in that by predicting protein structures and identifying optimal targets for the immune system.
That's right. I had almost forgotten about that. So AI can help us respond to outbreaks more quickly and effectively.
Exactly. And another important area the report highlights is nucleic acid synthesis screening. This is a security measure to prevent the misuse of synthetic DNA. AI can play a role here by helping to identify potentially dangerous DNA sequences before they can be used for harmful purposes.
It's like having an AI watchdog for synthetic biology.
Precisely. To further promote these positive allocations of AI, the report recommends that government agencies fund research on AI-enabled design tools for medical countermeasure development and establish public-private partnerships to ensure access to these tools and resources in an emergency response.
So the report is advocating for using AI to make the world a safer place.
Yes. But to fully understand how to do that, we need to dive deeper into the crucial role data plays in all of this. That brings us to Chapter 5, Importance of Data in AI-Enabled Biological Models.
All right, let's talk data. What are the key takeaways here?
Well, first and foremost, data is the lifeblood of AI. These models learn from data, and the quality and quantity of data directly impact their performance. So this chapter dives into the different levels of data accessibility, ranging from open source to classified information, and the challenges of balancing openness for scientific progress with the need for security when dealing with sensitive biological data.
That makes sense. You can't just let anyone access potentially dangerous biological data. But at the same time, you need to make enough data available for researchers to develop these AI models. It's a tricky balance.
Exactly. The report specifically mentions the National Institutes of Health, or NIH, and their evolving policies on data sharing. They're moving towards greater openness, especially for genomic data, which is exciting for researchers.
It is. But how do we manage all this data effectively? We're talking about enormous amounts of information.
That's where the need for robust infrastructure comes in. Think data repositories, powerful computing systems, and clear governance models to ensure responsible access and use.
So it's not just about having the data. It's about having the systems and structures in place to manage it effectively and securely.
Precisely. And the report gives some interesting examples of such infrastructure, like the database of genotypes and phenotypes, or DBGP, managed by the NIH. It also mentions the All of Us research program, which allows researchers to access and analyze health data from a diverse group of participants, although with some restrictions on training external AI models.
It sounds like these are valuable resources for researchers working in this field.
They are. The report goes on to stress the significance of national repositories for overall scientific progress, citing examples like the Protein Data Bank, GenBank for DNA sequences, and the Sequence Read Archive. These repositories require substantial long-term investment to maintain, but the payoff for scientific discovery is immense.
It seems like data is the key to unlocking the potential of AI in the life sciences, both for good and bad.
Absolutely. And that's why the report dedicates an entire chapter to this topic.
Well, we've covered a lot of ground in this first part of our deep dive.
We have.
But there's still more to unpack, especially regarding the potential vulnerabilities of data and AI models themselves.
There is. And we'll dive into those topics in the next part of our exploration. Stay tuned. Picking up where we left off, let's delve deeper into those data vulnerabilities we touched on at the end of the last section.
You're right, we were just starting to unpack the potential issues with the data itself. The report cautions against things like poisoned data sets and biased data. What exactly do those terms mean?
Imagine, like, someone deliberately inserting incorrect or misleading information into a data set used to train an AI model.
Ah, okay.
That's a poisoned data set. It could lead the AI to make faulty predictions or recommendations.
So it's like sabotaging the AI by feeding it bad information.
Exactly. And then there's biased data, which can be more subtle. It might reflect existing societal biases or inequalities, and if you're not careful, those biases can get baked into the AI model.
So if the data used to train an AI model for, say, diagnosing a disease is primarily from one demographic group, the model might not perform as well for people from other groups.
Precisely. And detecting and mitigating these problems is a constant challenge. We need to develop robust methods for ensuring data quality and fairness if we want to build reliable and trustworthy AI systems.
It makes you realize that data isn't just a neutral resource. It can carry hidden biases and vulnerabilities that we need to be aware of.
Absolutely. And that brings us to another critical point, assessing the AI models themselves. How do we know if they're giving us accurate information and not just making things up or behaving in unexpected ways?
The report mentioned things like red teaming and benchmark testing. What are those and how do they help?
Think of red teaming as kind of ethical hacking for AI.
Okay.
Experts try to break the model, find weaknesses, and see if they can trick it into making mistakes or revealing sensitive information.
Oh, interesting.
It's a way to stress test the model and identify potential vulnerabilities.
So it's like putting the AI through a rigorous obstacle course to see how it performs under pressure.
Exactly. And then there's benchmark testing, which is more about evaluating the model's performance against established standards. We want to know how accurate it is, how well it generalizes to new data, and how it compares to other models in its class.
So it's like giving the AI a standardized test to see how it stacks up against the competition.
Precisely. The report also mentions analyzing user interactions to identify potential problems. How is the AI responding to different prompts and requests? Are there any patterns of bias or error in its outputs?
It sounds like we need a whole suite of tools and techniques to thoroughly evaluate these AI models before we can trust them with important tasks.
We do, and the report emphasizes that this area of AI model assessment needs more research to develop even more robust methodologies and get consistently meaningful results. It's a rapidly evolving field, and we need to stay ahead of the curve.
Now, the report distinguishes between those general-purpose large language models, the LMs, like ChatGPT, and those specifically designed for biology, like CRISPR-GPT. Are there different approaches for assessing these different types of LLMs?
Yes, a one-size-fits-all approach won't work. We need tailored approaches that take into account the strengths and weaknesses of each type of LLM. For example, a general-purpose LLM might be great at generating creative text formats, but it might not be as reliable when it comes to understanding complex biological concepts.
So it's about choosing the right tool for the job and making sure it's up to the task.
Exactly. Now, before we move on, I think it's worth circling back to a point we made earlier about the potential impact of AI on other areas of biology.
You're right. The report primarily focuses on AI in the context of infectious disease, but its implications extend far beyond that. What are some other areas where AI could have a major impact?
Well, imagine the potential of AI in aging research. Could we use AI to identify the underlying mechanisms of aging and develop interventions to slow down or even reverse the process? Or think about the complex ecological systems that govern our planet. AI could help us understand these systems better and develop more effective strategies for conservation and sustainability.
Those are just a couple of examples. It seems like the possibilities are almost endless.
They are, and that's what makes this field so exciting. But as we've discussed, it's crucial to approach these advancements thoughtfully and responsibly, considering both the benefits and the risks.
It's a powerful reminder that AI is a tool, and like any tool, it can be used for good or for ill. It all depends on the intentions of the user and the safeguards we put in place.
Well said. Now, in its concluding remarks, the report summarizes several key considerations that are crucial for ensuring the responsible development and deployment of AI in the life sciences. It stresses that AI-enabled biological tools are still an emerging area of research. While there have been significant advancements, there are still limitations to what AI can currently achieve, whether for beneficial or harmful applications.
It's important to be realistic about what AI can do now and what it might be capable of in the future. So
Mhm.
what are some of those limitations? Where does AI fall short in the life sciences?
One important point the report makes is that AI-enabled biological tools primarily provide data-driven guidance for experimental validation. They're not a replacement for traditional scientific methods. AI can accelerate the process, generate hypotheses, and suggest promising directions, but ultimately, those suggestions need to be tested and validated in the real world.
It's a collaboration between human ingenuity and AI's computational power. They each have their strengths and limitations.
Exactly. And the report highlights the design, build, test, learn cycle, discussed in Chapter 2, as a framework for integrating AI into biological research. It emphasizes the iterative nature of this process, where AI-generated insights are used to guide experiments, and the results from those experiments are then fed back into the AI model to further refine its capabilities. It's a continuous learning loop.
So the AI is constantly learning and improving based on the results of real-world experiments. It's a dynamic process, not a static one.
Precisely. And the report also underscores the incredible potential of AI to enhance biosecurity responses. Whether in naturally occurring outbreaks or intentional events, it's not just about mitigating risks, it's about using AI as a proactive force for good. AI can bolster biosurveillance systems, improve infectious disease monitoring, and accelerate the development of medical countermeasures to protect us from a wide range of threats.
It sounds like AI could play a critical role in helping us prepare for and respond to future pandemics.
It could, and that's why responsible development and deployment are paramount. This report provides valuable insights and recommendations for navigating this complex landscape and shaping a future where AI benefits humanity while minimizing its risks. But there's one final point I think is worth highlighting before we wrap up.
Okay, you mentioned a final point from the report. What is it?
It's about the balance between data access and security. The report actually cautions against trying to restrict access to large amounts of biological data in the name of biosecurity.
That's interesting. Why would they advise against that?
Well, their argument is that restricting data access would likely hinder research more than it would help with security. They point out that the most advanced AI systems, even those used for things like clinical decision support and code generation, are built using something called foundation models.
I have heard that term before, but I'm a little fuzzy on the details. Could you remind me what foundation models are?
Think of them as large-scale models trained on massive amounts of general data. It could be text, images, even genomic data. Then, they're specialized for specific tasks using techniques like fine-tuning and prompt engineering.
So it's like they have a broad base of knowledge, and then you can train them to become experts in a particular area.
Exactly. And because of that, their capabilities are heavily reliant on having access to a wide range of data. Trying to limit that access would likely stifle innovation and prevent us from realizing the full potential of AI in the life sciences.
It seems like trying to control information in today's world is like trying to hold back a tidal wave.
You got it. And instead of focusing on data restriction, the report suggests prioritizing the development of those robust methods we talked about for assessing and mitigating the risks associated with the AI models themselves, things like red teaming and benchmark testing.
Right. It's about making sure the AI systems are behaving responsibly and not being used for harmful purposes.
Yeah.
We have to focus on the systems themselves, not try to lock down the data they learn from.
Precisely. It's also about ensuring those AI systems are transparent and accountable so we can understand how they're making decisions and identify potential biases or errors.
Transparency and accountability are crucial if we want to build trust in these systems. It sounds like we need a multi-pronged approach to biosecurity in the age of AI. Robust data infrastructure, careful model assessment, and clear ethical guidelines for development and use.
Well said. This report really highlights the complex interplay between scientific advancement, technological innovation, and societal implications. It's a reminder that we need to have these difficult conversations and make informed decisions about how to shape the future of AI in a way that benefits all of humanity.
This deep dive has been incredibly insightful. It's definitely given me a lot to think about.
Me too. And for our listeners, I encourage you to check out the full NASEM report, which we've linked in the show notes. It's a fascinating and important read for anyone interested in the future of AI and biology.
Great advice. Thanks for joining us for this deep dive. We'll be back soon with another thought-provoking topic.
Until then, stay curious and engaged.
See you next time.